Happy morning to all. Happy morning. Okay, anyhow, the last video, many of them wrote your assignment. And also, today we are going to discuss about that very important point, very important question, theory of coordination compound. Theory of coordination compound. Okay. Here, the previous class we discussed about the Vernier's theory. That is also one of the important questions. That is about the Alfred Vernier postulated that theory. And here also, we are going to discuss about that VB theory. That is a valence bond theory about that Linus Pauling. Pauling is proposed that theory. What is about this theory? He tell about that in the complex, the central metal atom and the ligand having a bond that is purely covalent bond. Which bond? Covalent bond according to his theory. Here, the bond is formed between the central metal atom and the ligand is due to the overlap of filled ligand orbital. Due to the overlap of filled ligand orbital containing a lone pair of electron. Containing what? A lone pair of electron. Here, what is important? What is our learning objectives means to learn about that main assumption of VB theory. Today, our learning objectives to learn about the main assumption of valence bond theory. I think that here are more than 9 or 10 points. It's very important for the 5-mark question. Very important for the 5-mark question. Especially low spin complex and high spin complex are very important for the 2-mark question. Okay, and about the strong field ligand, about the 2-mark question, I think that if you are learning this question, the one either means 2-mark question or 3-mark question or one-word question or any 5-mark question. It's a compulsory in our board examination. So everyone should learn this question. Only 10 points. If you are learning the 10 points, we can score a bit good marks. Please all of you take the note. We can be learn one by one for the 10 points. Okay. Please take all of you take the note. The valence bond theory. The valence bond theory was proposed by Linus Pauling. Okay, this is one of the question. The valence bond theory was proposed by Linus Pauling. What is about the valence bond theory? What we are going to learn about the valence bond theory? This theory explains about that the bond is formed between the central metal atom. Okay, the bond is formed between the central metal atom and the ligand. Okay, for example, one of the complex K4 FeCN6. This is one of the complex. Here, one of the bond is formed between, this is the central metal atom. This is what? Ligand. Here, he explained that a bond is formed between the central metal atom and the ligand due to a overlap of filled ligand orbital. Filled ligand orbital containing lone pair of electrons. Okay, containing lone pair of electrons. Okay, what is that? One of the bond is formed between the central metal atom and the ligand due to the overlap of filled ligand orbital. That filled ligand orbital containing lone pair of electron with vacant hybrid orbital. This is what? Valence bond theory. What is about the valence bond theory? I told you that this is one of the coordination complex, one of the compound, coordination compound. This coordination compound having one of the counter ion and also this is the central metal atom and this is also ligand. Am I right? Here, what is explained about the valence bond theory means one of the bond is formed between, this is the central metal atom and another one is a ligand. One of the bond is formed between the central metal atom and ligand. Why this happened means due to the overlap of filled ligand orbital, that filled ligand orbital containing a lone pair of electron with the vacant hybrid orbitals of the central metal atom. This is about the valence bond theorem. Here, what we are going to learn means, what our learning objective means, the main assumptions of valence bond theory. I think that is have more than 8 or 9 points. You should be learned. This is one of the important 5-mark questions. What are the main assumptions of valence bond theory? This is our today learning objectives. Here, that means the ligand metal bond in the coordination complex is a covalent in nature. The ligand and metal bond, the ligand and the metal bond in the coordination complex, one of the coordination complex is a covalent in nature. It's a covalent in nature. One of the key points is it is formed by sharing of electron. It is formed by the sharing of electron between the central metal atom and the ligand. It is a bond. It is formed by sharing of electron between the central metal atom and the ligand. This is about the first point. What is about the first point? The ligand, the metal bond is a coordination complex, is covalent. It is one of the covalent in nature. All of you know about that covalent. All of you know that one. It is a covalent in nature. It is formed by sharing of electron between the central metal atom. It is formed by the sharing of electron. Here the sharing of electron takes place where between the central metal atom and the ligand. This is about the first point. Can you learn the first assumption? Can you learn about the first assumption? What is the first assumption? It is formed by the sharing of electron. Sharing of electron between where? In the central metal atom and the ligand. Okay. It is formed by the sharing of electron between the central metal atom and the ligand. This is about the first point. The second assumption. What is the second assumption? Each ligand should have at least one filled orbital. Here having 6 ligand having here. What is about the ligand means? Each ligand should have at least one filled orbital containing a lone pair of electrons. This is the key point. One filled orbital containing a lone pair of electrons. Okay. Each ligand should have at least one filled orbital. Each ligand at least one filled orbital containing a lone pair of electrons. Can you learn the second point? What is about the first assumption? It is formed by the sharing of electron between the central metal atom and the ligand. Okay. What is about the first point? The ligand metal bond is a coordination complex, is a covalent in nature. It is formed by the sharing of what? Electrons between the central metal atom and the ligand. This is the first point. Here, what is about the second point? It is our character about the ligand. The ligand should have at least one filled orbital, containing a lone pair of electrons. It must have one filled orbital containing a lone pair of electrons. This is about the second point. Okay. What is about the third point? Anyhow, in order to accommodate the electron pair donated by the ligand, here the electron pair donated by the ligand are donating a pair of electron, the central metal atom present in the complex provide required number of vacant orbitals. This is the important point. What is about the important point? The central metal atom or ion present in the complex. This complex is, I think, an ion. This ion must present a complex provide a required number of vacant orbitals. That means the Fe required. It will be the metal ion present in the complex provide a required number of vacant orbitals. What orbital? Vacant orbital. About that assumption, the first point about the first assumption is tell about that. What is about tell about that? The sharing of electron between the central metal atom and the ligand. What is the first point? The sharing of electron between the central metal atom and the ligand. Okay. What is the first point? The sharing of electron between the central metal atom and the ligand. This is the first point. What is about the second point? It is goes to the ligand. The ligand, the filled orbital containing, each ligand must have the filled orbital. The filled orbital containing a lone pair of electron. Okay, a lone pair of electron. Next about that, the central metal ion present in the complex provide required number of vacant orbital. Required number of vacant orbital. Okay. These are the three main assumptions of valence bond theory. What is about the first point? Can you say what is about the first point? What is about the first point? It is formed by the sharing of electron between the central metal atom and the ligand. Okay. What is about the second point? Here having 6 ligand having, each ligand should have at least one filled orbital containing a lone pair of electron. What is about the third point? The central metal ion present in the complex provides required number of vacant orbital. Provides required number of vacant orbital. These are the 3 points, very important 3 points about the main assumption of valence bond theory. Let us begin to discuss the fourth point. Okay, how can you write the fourth point? Next about the fourth point. What is about the fourth point? This vacant orbital of central metal atom undergoes a process called hybridization. Okay. This vacant orbital of central metal atom undergoes a process called what? Hybridization. What is about hybridization? It is nothing but a mixing of an atomic orbitals. Okay. S orbitals combines with P orbital to form sp hybridization, like that. We'll learn some of the hybridization. Sp means linear, sp2 trigonal planar, sp3 means tetrahedral, dsp2 hybridization means square planar, and about that d2sp3 means octahedral, sp3d2 means octahedral. These are the hybridization. Okay, what are the hybridization? Sp, that's a very important point about the one-word question. What is the hybridization of sp? Sp means linear. sp2 hybridization trigonal planar, sp3 tetrahedral, dsp2 square planar, dsp3 trigonal bipyramidal, d2sp3 octahedral, sp3d2 octahedral. These are the hybridization. Anyhow, the vacant orbitals of central metal atom, the central metal atom having the vacant orbital, this vacant orbital undergo a process called hybridization. What is about the hybridization? The process of mixing of atomic orbitals of comparable energy. Mixing of atomic orbital. Atomic orbitals are mixing with comparable energy to form, what is our getting? To form equal number of new orbitals. During the hybridization, we got a new orbital, equal number of new orbital called a hybridized orbital with the same energy. Okay, anyhow, the fourth point tell about that a vacant orbital of metal orbital undergoes the hybridization. Okay, what is about the hybridization? The process of mixing of atomic orbitals of comparable energy. Comparable. What's the meaning of comparable energy? Almost or equal, not equal, comparable, comparable energy. Okay, the comparable energy of atomic orbitals to form equal number of new orbital, equal number of new orbital. That is called what? Hybridized orbital. The energy also same energy. Okay, what is about the fourth point? The vacant orbitals of central metal atom undergoes one of a new process called hybridization. What is about the hybridization? It is nothing but just mixing of an atomic orbitals of comparable energy. Okay, which energy? Comparable energy, not equal energy. Almost comparable energy. Atomic orbital having comparable energy to form equal number of new orbitals. We get equal number of new orbitals. That is called hybridized orbital. Which orbital? Hybridized orbital. This energy having same energy. What can you remember? What is about the first point? Can you remember about the first point? It is formed by the sharing of electron between the central metal atom and the ligand. Okay, it is formed by the sharing of electron between the central metal atom and the ligand. What is about the second point? Each ligand should have at least which orbital? Filled orbital. That filled orbital containing lone pair of electron. Okay, lone pair of electron. That is about the second point. What is about the third point? Here, in order to accommodate the electron pair donated by the ligand, the central metal ion present in the complex provide a required number of vacant orbitals. Okay, the central metal ion, suppose present in that complex, that central metal ion must provide required number of vacant orbital. That we called as a coordination number. I told you that about the coordination number. It is nothing but the total number of ligand that we are saying coordination number. Am I right? Okay, anyhow, the central metal ion present in the complex provide required number of vacant orbital. That is about the third point. Here, we are going to learn about the fourth point, that is called hybridization. What is about the hybridization? The process of intermixing of an atomic orbital of comparable energy. Each atomic orbital must have what? Comparable energy. Okay? Suppose comparable energy, it form equal number of new orbital. Okay, equal number of new orbital. That is called, that new orbitals are called hybridized orbital. Which orbital? Hybridized orbital. That hybridized orbital must have with same energy. Energies are same. Okay. Next about the fifth point. The vacant hybridized orbital of the central metal ions linearly overlap. Okay. Here, the vacant hybridized orbitals of the central metal ion linearly overlapping with filled ligand orbital. Okay. Linearly overlap with filled ligand orbitals of the ligand to form which bond we get? Coordinate covalent sigma bond. Which bond we get? Coordinate covalent sigma bond between the metal and the ligand. Now the metal and ligand have which bond? Coordinate covalent sigma bond. Which bond? Coordinate covalent sigma bond. What is about the fourth point? Here, the vacant metal orbital of the central metal atom undergoes hybridization. What is about the hybridization? The process of mixing of atomic orbitals of comparable energy. Which energy? Comparable energy to form equal number of orbitals, new orbitals. That is called hybridized orbital with the same energy. What is about the fifth point? The vacant hybridized orbitals of the central metal ion, the overlapping. How overlapping? Linearly overlapping. Okay, linearly overlapping with filled ligand orbital, filled orbitals with ligand to form coordinate covalent sigma bond. Okay. Next about the hybridized orbitals are directional in nature. Okay. The hybridized orbitals are directional and their orientation in space gives a definite geometry. It will be a geometry. What is about the geometry means? Suppose the hybridization is sp. The geometry is linear. Clear? Suppose the hybridization means sp. Sp means s orbital and p orbital. Okay. Sp means the geometry is linear. Suppose the hybridization is sp2, trigonal planar. Suppose the hybridization is sp3, tetrahedral. Okay, like that it should be learned as per the coordination number. The coordination number we are going to change. Okay, anyhow, what is about the, you must learn about the full point. This is a very important 5-mark question. Okay, what is about the main assumption of valence bond theory? First point, it is formed by the sharing of electron between the central metal atom and the ligand. Okay, here previously I told you about that ligand metal bond is in a coordination complex is a covalent in nature. It is a covalent nature. How it is formed? How it is formed means it is formed by the sharing of electron between the central metal atom and the ligand. And about the next, about the character of ligand, here each ligand should have at least one filled orbitals containing a lone pair of electrons. Am I right? Next about that, the central metal ion present in the complex, it provides a required number of vacant orbitals. These are the first 3 points. About the 4th point, we are going to discuss about that. What? Hybridization. What is about the hybridization? The process of intermixing of an atomic orbitals of comparable energy. Okay, not different energy. Okay, of comparable energy to form equal number of new orbital. We get a new orbital. That is called hybridized orbital. That new orbitals are called hybridized orbital. That hybridized orbital must have the same energy. Okay, not comparable energy, same energy. Okay, the hybridized orbitals must have what? Same energy. Okay, next about that, the 5th point. Here, the hybridized orbitals of central metal ions is linearly overlap. Okay, linearly overlap with filled orbitals of the ligand to form coordinate covalent sigma bond. Okay, which bond? Coordinate covalent sigma bond. Next about the 6th point. The hybridized orbitals are directional nature. Their orientation in space is a definite geometry. We get told geometry as per the hybridization, as per the coordination number, and the hybridization. We get the definite geometry. Okay, geometry for the complex ion. Okay. Next, we can learn about one of the tabular column about the coordination number, hybridization, and the geometry. Okay, these are the very important one word for the each one. What is the coordination number of coordination number 2 for coordination number 2? What is the hybridization? If the coordination number 2, what is the hybridization? Suppose the hybridization sp, what is the geometry? What is the geometry? That means sp means linear. What is the examples of linear complex? Which are the complexes are linear? Okay, we can discuss one by one. Okay. Okay, this point is very important for the one word. Each one is very important for the one word question, especially for the new students. In the coordination chemistry, they will ask one question must in the coordination compound. Okay, so you should be learned thoroughly. Coordination number, hybridization, geometry, and also the example. What is about the coordination number? I told you that the number of ligands that we are saying coordination number. Am I right? The complex number of ligands. Okay. Anyhow, the coordination number 2. 2 means the hybridization is sp. Suppose the hybridization sp means what is the geometry? Linear. Okay. The geometry is linear. And the example, I think that 3 or 4 examples having at least you should be thorough. Only one example is enough. Okay. What's the example? CuCl2 minus. Okay. Example. What is about the second one? Suppose the coordination number is 3. Coordination number is 3. What is the hybridization? sp2 hybridization. sp2 hybridization means what is the geometry means trigonal planar. Okay. What is the example? Hg I3I. Okay. I3 minus. Okay. Next one. Coordination number 4. Coordination number 4 2 having one is the hybridization is sp3. Suppose sp3 hybridization means coordination number 4 with sp3 hybridization means it is a tetrahedral. What is the example? NiCO 4 times. Okay, NiCO 4 times. Okay. Coordination number 4 means sp3 hybridization. sp3 hybridization means tetrahedral. Suppose the coordination number 4 with the hybridization dsp2 means it is a square planar. Okay. Don't forget that we have 4 coordination number 2 having. One is coordination number sp3, coordination number 4 with dsp2. Coordination number 4 with sp3, coordination number 4 with dsp2. Suppose coordination number 4 with sp3 means, don't forget the geometry, it is a tetrahedral, and coordination number 4 with dsp2, it is a square planar. Don't forget that the example. Okay, can you say this complex name? Anyone can you say this complex name? CO is which ligand? Positive or negative or neutral? Neutral ligand. How much carbon is there? 4. Okay, tetracarbonyl, nickel, Roman letter 2. Amen. Roman letter 2. Okay. Next one. Coordination number 4. What is about the hybridization? dsp2 square planar. Square planar. Okay. And about the example. What is the example? Nickel Cn4 2 minus. Okay. Next about coordination number 5. What is the hybridization? dsp3 trigonal bipyramidal. Trigonal bipyramidal. What is the example? FeCO 5 times. Okay, FeCO 5 times. And about here 2 more coordination number 6. One is d2sp3. Another one is the sp3d2. One is what? d2sp3. Another one is the sp3d2. Both are same octahedral, but the examples are different. Okay, anyhow, coordination number same, hybridization d2sp3, sp3d2. Okay, but the geometry is both are same octahedral. And about that, d2sp3, what is the example means? FeCN6 2 minus. And about the sp3d2 means hybridization is geometry is octahedral. And about the example is FeF6 4 minus. Anyhow, here d2sp3 octahedral. About this example, it is an inner orbital complex. Okay, inner orbital complex. This one is the outer orbital complex. Here, what is about the inner orbital complex? What is about the outer orbital complex? Let us discuss about the 7th point. And one more point is, what is the other name of inner orbital complex? Means low spin complex. Okay, low spin complex, and another one more name also having spin paired complex. Okay, low spin complex means inner orbital complex, low spin complex or spin paired complex. Okay, and about the outer complex also like having the name outer orbital complex means here having the name is about that high spin. Okay, about that high spin complex, spin free complex. Okay, outer orbital, other name is high spin and spin free complex. Okay, let us, what is the meaning of here? We are about the low spin complex and high spin complex. We can discuss about the 7th point. Okay, about the 7th point, I told you that what is the inner orbital complex and what is about the outer orbital complex. Okay, it is only for the octahedral complex. Okay, only for the octahedral complex. If the n-1d orbitals are involved in hybridization. Okay, it is only for the octahedral complex. In the octahedral complex, if the n-1d orbitals are involved in hybridization, okay, then they are called as inner orbital complex. Here, what is the condition? if the n minus 1 d orbitals are involved in hybridization. If the n minus 1 d orbitals are involved in hybridization, then they are called as inner orbital complex. What is the other name of inner orbital complex? Low spin complex. What is the other name? Spin paired complex. Spin paired complex. Okay, these are very important for the 2-mark question. What is about the inner orbital complex? In the octagonal complex, if the n minus 1 d orbitals are involved in hybridization, okay, they are called as what? Inner orbital complex. Otherwise called low spin complex. Otherwise called what? Spin paired complex. Suppose if the nd orbitals involved for the hybridization, nd orbitals, okay, nd orbitals are involved in the hybridization, they are called as what? They are called as outer orbital, otherwise called high spin, otherwise called spin free complex. Okay, sometimes it may be asked about the 2-mark question. What is about the low spin complex? What is about the high spin complex? What is your answer? Low spin means, don't forget that, if the n minus 1 d orbitals are involved in hybridization. What is about the high spin? Nd orbitals are involved in hybridization. Here, what is about the n? N represent the principal quantum number. Okay, principal quantum number. Okay, that is about the 7th point. What is about the 8th point? If the complex containing the central metal atom with unpaired electron, don't forget that, with unpaired electron means it is called a paramagnetic. With unpaired electron means paramagnetic, and with the complex with paired electron, okay, are called as a diamagnetic. The 8th one is also very important question, very important point. The complex containing the central metal atom with unpaired electrons are what nature? Paramagnetic in nature. If all electrons are paired in the complex containing all electrons are paired, that we are called as what? Diamagnetic. Okay, which one? Diamagnetic. Next, about the 8th one is also one of the definition. What is about the strong field ligand? Okay, the ligand such as CO. What is about the CO? We are saying what? Carbonyl is one of the literal ligand. Okay, CO. About CN minus. Okay, CN, Sindo, CN. And EN. What is about the EN? Ethylene diamine. Okay, and ammonia, NH3. Amine. We are saying amine. These are the ligands such as CO, Cn minus, En and NH3 present in the complex cause pairing of electron present in the central metal atom. Okay, here pairing of electron takes place. Which electrons takes place? Pairing of electrons cause the pairing of electrons. Okay, that pairing of electrons, such type of ligands are called as strong field ligand. Which field ligand? Strong field ligand. Okay. What is about the 9th point? The ligands such as CO, Cn minus, En and NH3, that is carbonyl, sido, ethylene diamine and also amine present in the complex cause pairing of electron present in the central metal atom. Pairing of electron. These are a pairing of electron present in the central metal atom. Such type of the ligands are called as strong field ligand. Okay. Next, about the 10th point, a very important point about the one-word question. Greater the overlap between the ligand orbital. Okay. One of the important one-word question. Greater the overlap between the ligand orbitals and the hybridized metal orbitals is greater than the bond strength. Okay, the greater the overlapping between the ligand orbitals, and the hybridized metal orbital, greater is the bond strength. Okay, At least you should be thorough with 7 point. At least make it 7 point. Okay. What is the first point? The main assumption of VB theory. What is about the? Anybody remember the first point? Don't forget that the coordination compound, that means ligand metal bonding coordination complex is covalent in nature. One way question. Which nature? Covalent in nature. How it is formed? It is formed by the sharing of electron between central metal atom and the ligand. Next about the ligand character. Each ligand have at least one filled orbital containing a lone pair of electron. Okay, each ligand should have at least one filled orbital containing a lone pair of electron. What is about the third point? The central metal atom present in the complex provides the required number of vacant orbitals. Okay, required number of vacant orbitals. Next about the process hybridization. The fourth point. What is about the hybridization? Here, the process of mixing of atomic orbitals of comparable energy to form equal number of new orbital, that is called hybridized orbitals. Okay, that is called what? Hybridized orbital. Okay, and about the fifth point, the vacant hybridized orbitals of central metal ion linearly overlap with filled ligand orbitals to form, what is the bond? Coordinate covalent sigma bond. Coordinate covalent sigma bond. Next about the hybridized orbitals are directional in nature. Hybridized orbitals are directional and their orientation in space gives a definite geometry to the complex ion. We get the geometry to the complex ion. For example, what is about the fifth condition? One of the condition is coordination number 2 means hybridization is SP. Okay, suppose the hybridization means SP means linear, SP2 means trigonal planar, SP3 means tetrahedral, DSP2 means square planar, DSP3 trigonal bipyramidal, D2SP3 octahedral, SP3 D2 octahedral. Okay, next about the seventh point is especially very important point to the seventh point about the 2 mark question. In octahedral complex, if n-1d orbitals are involved in hybridization, that we are saying inner orbital complex. Okay, what? Inner orbital complex, otherwise called low spin complex, otherwise called spin paired complex. Suppose if the hybridization involved in where nd orbitals, that we are called outer orbitals, or high spin or spin free complex. Okay, next about the 8th one, the complex containing central metal ions with unpaired electron. The unpaired electrons means paramagnetic and the electrons are paired means what? Diamagnetic in nature. Its nature, diamagnetic in nature. Okay, next about the 9th point. Here the ligands such as ligand carbonyl, that is CO, cyanido, Cn minus, ethylene diamine, En, and amine, NH3, present in the complex cause pairing of electron present in the central metal atom. Such ligands are called strong field ligands. Okay, important points, very important point. What are the strong field ligands? That is the 7th point and also the 9th points are very important. And about the one better question, greater the overlap between the ligands orbitals and the hybridized metal orbitals are greater is the bond strength. Greater is the bond strength. Okay. And next about that, please, this is my humble request. Please, all of you, please, you should be learn this question thoroughly. Before the video, I told you about the Vernier's theory. The Vernier's theory also is a very important question. Here also the valence bond theory. Valence bond theory. So it's a very important question for the 5 mark question. Vernier's and the valence bond theory. It's a compulsory question. Okay. Don't forget that. Please, all of you learn this Vernier's theory. At least you should be learn. At least in your side, at least you should be learn any 7 point. Okay. Those who can learn 10 point is okay. I welcome you. Otherwise, you should be learn any 7 point. Okay. Easiest 7 point. Okay. Assignment. VB theory. Thank you all of you. Thank you. Have a nice day.